We are going to do Pythagoras theorem applied on right angle triangle. This is a right angle triangle, and the side which is opposite to right angle is hypotenuse. And hypotenuse is the longest side of the right angle triangle. Now, the other two sides are not supposed to be marked as perpendicular and base, because perpendicular and base is to be marked when there is angle involved. In Pythagoras theorem, there is no angle involved. Other than 90 degrees. The angle which is involved is only 90 degrees. Now, if there is no angle involved, we have to take one of the side as A and another side as B. And the hypotenuse is to be taken as h. So according to Pythagoras theorem, square of hypotenuse is equal to sum of square of other two sides. Let's solve an example. We have this triangle in which this side is 12 centimeter and this side is 5 centimeter, and you have to take out this. As you know, the side which is opposite to right angle is hypotenuse. So we can mark this as hypotenuse. We can say this is A and we can say this is B. So when we will substitute it in the formula of Pythagoras theorem, we have hypotenuse square is equal to A square plus B square. In place of hypotenuse, we will substitute x. X square is equal to 5 square plus 12. X square is equal to 25 plus 144. So x square is equal to 169. X is equal to square root of 169. Then x is equal to 13 centimeters. Do we have to write here plus and minus? No, because we are taking out length and lengths cannot be negative. Let's solve another example in which this side is given as 4 centimeter and this side is given as 5 centimeter. And you have to find out this side. Now, if you see 5 centimeter is opposite to right angle, so we will say this is hypotenuse. And this you can say as A and this you can say as B. So now you have to substitute it in Pythagoras theorem formula, which is hypotenuse square is equal to A square plus B square. Hypotenuse is given here, which is 5. A we have to take out, which is x, and B is given, which is 4. We'll solve it, we'll simplify it. X square plus 16. So 25 minus 16 is equal to x square, and x square is equal to 9. Now we can take out square root. We can take square root of 9 to find out the value of x. So x is equal to 3 centimeters. Pythagoras theorem is not just a tool for calculating the sides of a right angle triangle. It can also be used to prove whether a triangle is right angle or not. For example, if we have A is equal to 6 centimeter, B is equal to 8 centimeter, and C is equal to 10 centimeter. And we have to prove that the triangle is a right angle triangle. Then what we have to do? We have to substitute these values in the formula hypotenuse square is equal to A square plus B square. Now, the point is that which of the sides we have to take A and B and which of the sides we have to consider as hypotenuse. The longest side is the hypotenuse. So we will consider here 10 as hypotenuse. So 10 square is equal to 6 square plus 8 square. So we have here 100 is equal to 36 plus 64. So 100 is equal to 100, which proves that the triangle is a right angle triangle. Let's do another example whose sides are A is equal to 4 centimeter, B is equal to 5 centimeter, and C is equal to 9 centimeter. And we have to prove whether this triangle is a right angle triangle or not. We will consider the longest side as hypotenuse. So hypotenuse square is equal to A square plus B square. In this case, we have 9 square. We'll consider 9 as hypotenuse because it is the longest side. 4 square plus 5 square. So 9 square is 81 and 4 square is 16 and 5 square is 25. 81 is equal to 41. And we can see that these two are not equal. So we can write here 81 is not equal to 41. And we can say that the triangle whose sides are 4 centimeter, 5 centimeter, and 9 centimeter is not a right angle triangle. We are going to do trigonometric ratios. In trigonometric ratios, angle is involved, while in Pythagoras theorem, angle is not involved. Now, angle is either given or we have to take out to be found. Now, we have this right angle triangle and we know that the side opposite to right angle is hypotenuse. The angle is here, which is theta. Now, here angle is involved. The side opposite to angle is perpendicular, and the side on which there is angle, that is called base. Perpendicular and base are not of triangle. They are of angle. The side opposite to theta is perpendicular, and the side which is next to angle is base. We have three trigonometric ratios: sine theta, which is equal to perpendicular upon hypotenuse. Then cos theta, which is equal to base upon hypotenuse. Tan theta, which is perpendicular upon base. Remember a mnemonic, which is some people have curly brown hair, still painted black. S is equal to P upon H, C is equal to B upon H, and T is equal to P upon B. So this is the way you can remember these trigonometric ratios. Now, this is the case where the angle is this one. But if in case the angle is marked over here, then perpendicular and base will be different. Hypotenuse is the same, the longest side, and opposite to right angle. If this is theta, then this is perpendicular. The side opposite to angle is perpendicular, and the side which is next to the angle is base. Trigonometric ratios involve angles, so you have to mark perpendicular and base according to the angle, and then you have to apply the trigonometric ratio. Let's do an example. In the triangle, if this angle is given as 30 degree and this side is 16 and this side is x. First of all, you will mark the sides, that which side is hypotenuse, which is perpendicular, and which is base. As we know, this is opposite to right angle, so this is hypotenuse. This side is opposite to angle, so this is perpendicular. And this is the side which is base. Now, the side which is not given or not to be found, is this one. Cross out this side. We have perpendicular and hypotenuse. If we see trigonometric ratios, we have perpendicular and hypotenuse is sine. So we can write here sine theta is equal to perpendicular upon hypotenuse. Then we will substitute the values here. Theta is 30 degree. So we will write theta 30 and then x upon 16. Now you will do cross multiplication. So 16 will be written before sine 30. So x is equal to 8. Let's see another example in which the angle is given here 60 degree. This side is 30 and this side is unknown. First of all, we will mark the side opposite to the right angle is hypotenuse. The side which is opposite to angle is perpendicular. The side which is next to the angle is base. Now we'll see the side which is not given, or we have to find is P. So we will cross out this. Now we have base and hypotenuse, and base and hypotenuse is there in cos. Base upon hypotenuse is equal to cos theta. Now we'll substitute the values. Cos 60 degree is equal to base is x and hypotenuse is 30. Now we'll do cross multiplication. 30 cos 60 degree is equal to x. So x is equal to 15. We have to use calculator to find out 30 multiplied by cos 60 degree. Let's do another example. In this, the angle is given here 60 degree. This is the side which is given as 3. This is the side which is given as x. First of all, we will mark the sides. The side opposite to right angle is hypotenuse. The side opposite to angle is perpendicular. And the side which is next to angle is base. This is the side which is not given or which we have to take out. So we have to cross out this. We have perpendicular and base. Perpendicular upon base is equal to tan theta. So we'll use here tan theta. Theta is 60 degree. Perpendicular is 3. And base is x. So we have base which is unknown, and if it is in denominator, so we just have to switch the places. X is equal to 3 upon tan 60, which is equal to under root 3. Let's see another example. In this, the angle is here x, which is unknown. This side is given as 3, and this side is given as 4. First of all, we will mark the sides. The side opposite to right angle is hypotenuse. The side which is opposite to angle is perpendicular. The side which is next to angle is base. We will cross out the side which is not given or which we don't have to take out. So this one is the side which is not given and which we don't have to take out. So now we will see we have here 3, which is base, and 4, which is perpendicular, and we have to take out angle. We have perpendicular and base. So perpendicular upon base is tan theta. Now we'll substitute the values. Tan x is equal to 4 upon 3. Now we have to take out x. So x is equal to, when we will take tan on that side, it will become tan inverse. So x is equal to tan inverse of 4 upon 3. We'll be using shift and tan key. Then there will be bracket. You will be writing 4 divided by 3 in the bracket. You can even enter in the form of fraction, which will give the answer as 53.13. So x is equal to 53.13. And we have to write down the answer correct to 1 decimal place. So 53.1 degree to 1 decimal. Let's do another example. This is the right angle triangle, which is given. This side is given as 7. This side is given as 10. And this is the angle which you have to take out. So the first step is that we have to mark all the sides. The side opposite to right angle is hypotenuse. The side opposite to angle is perpendicular. And the side next to angle is base. This is the side which is not given or which we have to take out, so we'll cross out this. We have perpendicular and hypotenuse. Perpendicular upon hypotenuse is sine theta. So sine x is equal to, perpendicular is 7, hypotenuse is 10. So x is equal to sine inverse of 7 upon 10, which is 44.42. And when you round it off to one decimal place, it will be 44.4 degree, which is rounded off to one decimal. Let's solve another example. This is the side which is 9. This is the side which is 11. And this is the angle you have to take out. First of all, we'll mark which side is what. The side opposite to right angle is hypotenuse. The side opposite to angle is perpendicular. And the side which is next to angle is base. This is the side which is not to be taken out and which is not given. So this is to be crossed out. We have base and hypotenuse, and base upon hypotenuse is cos theta. So cos x is equal to 9 upon 11, and x is equal to cos inverse of 9 upon 11. X is equal to 35.09, and x is equal to 35.1 degree, rounded off to one decimal.